Hello again. We are back on our complex numbers. We're going to talk about now the operations on the complex numbers. Last time we have introduced the imaginary part. We have talked different examples about how we can simplify different expressions depending on the set of complex numbers. So you can check on this. You can check that video and you can add a comment. You can subscribe. And here also, don't forget to subscribe. Don't forget to add notification. Don't forget to hit like. So when we're talking about the operations on complex numbers, first of all, we'll introduce, as we have seen, the complex numbers is the combination of the real part and the imaginary part, the real numbers and the imaginary number, especially in two dimensions. So we say that if we have set Z, which is equal to A plus BI. Normally, here we say that where this A is a real part, and BI is the imaginary part. For these two expressions, A is a real part, this part is a real part, and this BI is the imaginary part. So we say that this is a real and this is the imaginary. And then always this A and B are real numbers. A and B are real numbers. So for this expression, this is called the algebraic form of a complex number. Then when we're talking about the operations, we can start by conjugate. The conjugate of a complex numbers. A conjugate of a complex number, if we have set Z, which is equal to X plus YI, if we have this set, automatically Z conjugate, we use this symbol, or we use Z conjugate like this, it is equal to X negative YI. It means we change this middle sign, or we change the sign of the imaginary part. When you try to put on a graph, we have this Y, this is X, and then where they join, let's say that we have a set Z. We have a set Z here, Z which is equal to X plus YI. Then its conjugate, if you have like this, its conjugate, it is down. Its conjugate is here. This is Z conjugate, which is equal to X negative YI, like this. This is its Z conjugate. That is how we find the conjugate of a complex number. So we can say that if, an example, Z is equal to 3I positive 1, then Z conjugate is equal to what? Here, our Z conjugate is equal to what? As we have seen, we change the sign of the imaginary part. Change the sign of the imaginary part. And here, what is the imaginary part here? The imaginary part is automatically 3I. Because this is real, with a real number without the imaginary number, then this with the imaginary number is called the imaginary part. So we can say that this is 1 negative 3I. Another question, let's talk about what you call the equality of a complex number. If we have two sets, if we have z1 which is equal to a plus bi, and z2 which is equal to x plus yi, then we say that z1 is equal to z2 if and only if z1 is equal to z2 if the real parts are equal, a is equal to x and bi is equal to yi. It means that two sets of complex numbers are equal only if their real parts are equal and their imaginary parts are equal. You understand the and? And means none of those two parts can be different for two equal complex numbers. Do you understand? Any question? You can drop it in a comment. I'm going to read all comments there. You can put it in a comment if you have any question. Let's discuss about it. For example, you can use this property of the equality when you are trying to solve different expressions involving, or different equations involving this kind of expression of equality, like solve or find the value of x and y if we have 2x plus y plus I times y negative 5 equal to 0, like this. We need to find the value of x and y for this expression. What will happen? As we have seen, this one is considered to be one complex number. Because it is z1, it can be z1 or z2, it has a real part, which is 2x plus y without the imaginary number, and it has the imaginary part with the imaginary number. And as I said, this one is called the algebraic form. And then, for another part, for right side, we don't have set z. And even if it is not there, but it is there with zeros. The real part is 0, and the imaginary part is 0. We can say that we have set z2 which is equal to 0 plus 0i, like that. Then when we are going to compare, as I have said, a plus a is equal to x, real parts are equal. 2x plus y is equal to 0, because they are the real part, this one, and also this one, y negative 5 is equal to 0, because this one is the imaginary part, which is this, is equal to the imaginary part of this, and the real part is equal to the real part of this. So we have now a simultaneous equation to solve. According to this, we see that y is equal to 5. And according to this, if y is equal to 5, automatically this 2x plus y is equal to 0, 2x is equal to negative y, 2x is equal to negative 5, then x is equal to negative 5 over 2. So, those are the value of x and y, such that this expression, this real part, 2x plus y, adding with this imaginary part, y plus 5, it will be equal to 0. This is about the equality of these two complex numbers.